So today we're going to be finding the distance between two points. And it's hard to see these red lines here, but really you can see this one over here on the right side. Just need to count how long the line is, or segment actually. 1, 2, 3, 4. So that would be 4 units long. This one here, how long would this one be? And it would be 6 units for this one right here. So those are easy when they're straight up and down on the graph. You can just use the graph to count. But of course they're not all going to be that easy. So let's look at this, and let's do this one right here first. So if I want to know this distance, and it might be off a teeny bit, so let's make sure it does go from corner to corner there. Do you see anything we could use that we've done recently that would help us find the distance? So if you really think about it, you could make a little right triangle here, couldn't you? Here would be our right angle, so this would be the side C. How many units is this? Well, we can count straight across as 3, and how many units of this? This is 4. So we use 3 squared plus 4 squared equals C squared. 9 plus 16 equals C squared. And please write equations like this. Don't kind of just slop it down everywhere, which some of you were doing. Then we would take the square root of each side, and we would get 5 equals C. So it's applying what we've been using. We can see where we can use Pythagorean theorem. So we can use the same idea here. We can make a right triangle, and this would be the C. So my equation would be each side here. It looks like it's 2 long. So 2 squared plus 2 squared equal C squared. So 4 plus 4 equals C squared. 8 equals C squared. But again, we don't want C, so we take the square root. And let's round the square root of 8 to the nearest tenth. It's going to be 2.8 units is what C is going to be. So just making right triangles out of them and then using that. Okay, again, we're going to make our right triangle. So draw it in. And if they don't look like they go to whole numbers, make them look like that. There we go. So we need to figure out how long each side of the right triangle is other than the C here. So we have 1, 2, 3, 4, 5, 6, 7 for this side, looks like. 1, 2, 3, 4, 5, 6 for this side. So we get 6 squared plus 7 squared equals C squared. 36 plus 49 equals C squared. Add those together, you're going to get 85 equals C squared. But again, we don't want C squared, so we take the square root of each side, rounding to the nearest tenth, 9.2 units long. So that's how you can do it in a picture form. Well, what this leads to is what's called the distance formula. I guess I should have shown you back on that last one. Let's go backwards a slide. That really, if you think about the, whoops, that's going to take me forward the slide. If we think about the coordinates of this point, okay, it's -1 and 1, 2, 3, 4. So -1, -4. Okay, and you think about the coordinates of this point, it is 1, 2, 3, 4, 5, 1, 2, 3. So it is 5, 3. So we can kind of use that idea to, in this, what we call the distance formula, to figure out how far this is and how far this is compared to that. So that's where this distance formula came from in this next one. So if you're given an ordered pair, x sub 1, y sub 1, 2 ordered pairs actually, x sub 2, y sub 2, you can find the distance between them by putting them in this, which is a form of the Pythagorean theorem. In other words, d squared equals this would be the Pythagorean theorem, and they've already taken the square root. So we're going to just put this in. This would be like x sub 1, y sub 1, and this would be like x sub 2, y sub 2. Technically, it doesn't matter which one's first. So d is going to be equal to the square root of -4 minus 2, and then we got to square that, plus the distance between the other two would be 5 minus 3, the y-coordinates squared. So make sure you know your integers, add the opposites. This is -6 squared, so it's going to be a square root of 36, plus, that's going to be 2, 2 squared, 4, and then 36 plus 4 is going to be 40, so let's come over here and get this. So the square root of 40 equals d, and the square root of 40 would be 6.3 equal d. So that's how you can use the distance formula to help you do this. So you subtract the x-coordinates and square them, subtract the y-coordinates and square them, and then take the square root after you add those two together. So let's see if we can do it on this one. So the distance is equal to the square root of, I'm going to take my two x's, and like I say, it doesn't really matter. If you would prefer to put the first x first, you can. Just make sure you're consistent on the y's as you do that. Okay, plus, now since I use this first, I need to use this first. 3 minus negative 5 squared. This becomes plus positive, which would be 9. 9 squared would be 81. Plus positive would give me 8. 8 squared would be 64. 81 plus 64 is equal to 145, and take the square root of 145, round it off, it's actually 12.0. Remember, you do need that 0 there to show it's been rounded to the nearest tenth. So that's using the distance formula then.